Any discussion of digital imaging has to begin with an explanation of the two basic types of digital imaging files. Those two types are raster and vector. I will go ahead and just type those out here so you can see them. There's raster, and then over here I will put vector. I'm going to begin with raster images because raster is something that, whether you know it or not, you are already familiar with. Over here, I have a raster image file open. This is one of the rooms in the CVA building, and this is a raster file. There are a few ways that I know it's a raster file. The first is that if I leave Photoshop briefly, I can go ahead and I can open this file up, and it opens in my computer's standard image viewer. There it is. This is a JPEG file, and I know from experience that all JPEG files are Raster Graphics. A raster graphic is any image that's made up of a grid of pixels. And to explain what a pixel grid is, I'm going to take this image and I'm going to zoom in on it. I'm going to zoom in an awful lot. And as I get closer and closer to the image, you can start to see it break down into a series of tiny boxes. You can see it here a bit better than you can here in the black. I'll keep going and going and going. This is a pretty big image. But now we can really see the individual boxes that make up this file. Any raster graphic is made up of a series of boxes like this one. I will zoom back out, and back over here I will talk about what those boxes mean. I've got this little grid up on my screen. And if I were to turn this into a raster graphic, what I would do is I would start drawing lines. And this would be my ultimate image size. So in this case, my image is 1, 2, 3, 4, 5, 6 units, so we'll write a 6 right there, by 1, 2, 3, 4, 5 units. So this is a 6 by 5 unit image, and the units in a raster graphic are called pixels. P-I-X-E-L. To go even finer, I could outline each of these boxes. I will do that next. So 1, 2, 3, 4, 5 by, Control Z that, 1, 2, 3, 4. Now, each of these boxes has to carry a lot of information in its head. So if I look at this box right here, the first thing that it needs to know is where it is in the grid. So it has an X, Y coordinate. This would be, let's see, that's 1, 2, 3, 4, 5, 6, so that would be 6x 5y. And I would write it like that. So every single box needs to know where it is within the grid. The other thing each box needs to know is what color it is. And in Raster Graphics, this is very specific. Each box contains a percentage of color, And the three colors that Raster Graphics work with are the three primary colors: red, green, and blue. And that's the first thing that I've said that some of you have probably looked at and just gone, wait, what? Because you've probably been taught that the three primary colors are red, yellow, and blue. When we talk about digital imaging, what we're talking about is the amount of light that comes out of the computer screen, or your phone screen, or your television screen, or a movie projector. It's all about light. Light color breaks down using a concept called additive color mixing. So I'll write that here, additive color mixing. In additive color mixing, we use the visual spectrum, Roy G. Biv, red, orange, yellow, green, blue, indigo, violet. The three primary colors there break down into red, green, and blue. The way you've been taught to do color mixing with crayons or paint or whatever you've used is subtractive color mixing. Subtractive color mixing uses pigments, as in paint. As you mix the pigments together, they return less light, they get darker. That's why we use yellow as one of the primaries. It's a weaker pigment. It mixes to form green. When we deal with straight light color mixing, as you mix pigments together, they become brighter. So if I had pure pigmentation, 100% red, 100% green, and 100% blue, that would give me white. 0% red, 0% green, 0% blue would give me black. To check that out, I can come back over here. I see I've got some really intense reds. This looks like white up here, and I've got some blacks down in here. In Photoshop, I can look at my different image channels. Here's red, and you can see that on my red image, this is very close to white, this is very close to black. On my green image, again, this point is white, this point is black, and on my blue image, this point is white, this point is black. When they mix together, this point is white, this point is black. Now, I mentioned earlier that these books here are red. If I look at the red image, they appear to be white. If I look at the green image, they appear to be black. And the same thing with the blue image, they appear to be black. That's because they have a high percentage red and a low percentage green and a low percentage blue. When I put the image together, they come up just as red. So back here, every single pixel, every single box in this grid needs to know its XY location and its percentage red, percentage green, percentage blue, so that it can combine for my additive color mixing. Some raster graphics go a little bit further, and in addition to simply knowing red, green, and blue, they contain other types of data, like alpha. Alpha is transparency information. And I'm trying to write in script with my mouse, which is pretty tough. A-L-P-H-A, alpha. Alpha is transparency. Other raster image types contain luminance or luma data, so that's L-U-M-A, luma. Luminance information, if you had camera raw data, you could affect the way that light works in your image based on the luminance information. Now, If the image type you're working with has alpha or luma, then every single pixel needs to know that alpha and that luma in addition to its location XY and its percentage R, G, and B. This means that raster graphics tend to be a little bit on the heavy side. They tend to take up more space. If I look over here in my file browser, this image file that I was looking at is 4,000 kilobytes. It's pretty small for an image file, but it's pretty big compared to other things. So raster graphics, each pixel contains a lot of data, and that means that the files tend to be a little bit on the heavy side. That's a disadvantage because it means that they take up a lot of disk space and can be difficult to edit. On the positive side, raster graphics are extremely common. I went over to Google to pull up a list of raster graphics, and what I got, even before I went to any website, was this amazingly long list that just goes all the way across my screen. You are familiar with most of these types. The portable network graphic is the PNG. There's your GIF or your GIF. There's a JPEG. There's a TIFF. There's a raw image format, a BMP. It just goes on and on. The rule of thumb that I have is that raster graphics can be viewed without any kind of specialty software. If you're looking at a picture on a web page, whether you're using your phone, your television, your computer, whatever it is, if you're just looking at an image, it is probably a raster graphic. So they are really easy to share with other people, and that is a big advantage for them. So remember, raster graphics work on a system of pixel grids. They tend to be heavier, but they are extremely good for sharing. I will pause this here, and when I come back, I will talk about vector graphics.